Welcome back to Aurora Tech Channel. About a year ago, I got my Prusa MK3S Plus, and since then, I haven't done any upgrades on the printer itself because of how well it prints. I only added a Raspberry Pi with Octopi so that I could send prints directly from my computer. Today, I will test out this Quinly Automation 3D Printing System kit from 3DQ on the Prusa MKS series. This allows you to do batch printing, to eject parts when the print is finished, and to start a new one. You can control the print queue by changing the number of parts you need to print or adding more jobs to the queue. This kit also comes with an optional wireless hub in case you don't have a Raspberry Pi or you cannot get one in this chip shortage pandemic. I would like to thank 3DQ for sending me this kit to review, and with that, let's get started. We have two 30 by 30 aluminum extrusions, a vapor print surface, some 3D printed parts, a USB Wi-Fi adapter, the wireless hub, and the power supply. First, I will clean my existing print surface as I need to stick the vapor print surface on top of it. However, don't use isopropyl alcohol on the vapor surface. Remove the filament holder and the LCD screen from the printer. Put the tilted mount on the extrusion and install one to each side so that your printer is now tilted. Install two covers to make sure no parts go underneath the heated bed. Add a slider using the spacer and screws of the heated bed. Replace the support 3D printed parts of the LCD screen with the ones that came with this kit. Mount it on top of the frame, reconnect the cables, and use zip ties for some cable management. Mount the wireless hub at the side of the printer and connect the USB cable from the hub to the printer. Connect the power cables, the USB webcam, and the USB Wi-Fi adapter, or if you have an Ethernet cable, using a wired network is always better. Now we can turn the printer on and the wireless hub on. After 8 to 10 minutes, the printer will show an IP address. We need to turn off the two features in the settings menu. We need the crash detection off and the Raspberry Pi port off. We also need to adjust the Super Pinda sensor, and making it 1 mm higher than the nozzle is recommended. Then redo the first layer calibration. Once you get the filament to stick to the print surface, we can go to the computer and make some changes to our slicer profile. First, for print settings, set a thicker first layer height, as we want a thicker first layer for better adhesion. For the layer height, you can just set it to your normal layer height like 0.2 or 0.3, but as I want to print faster for the test prints, I will just set it to 0.4. I will add a few more loops to the skirt to clean up the nozzle, set the distance closer to the model we print, and set the height of the skirt to be taller so it can be removed easily along with the model. For filament settings, we need to increase the temperature by at least 10 degrees as the print surface is now thicker. The measurement from the thermistor under the bed closer to the heat source may not be the same as our print surface. For the printer settings, clear all the start and end G-code. Okay, that's all we need to change. Let's start with a simple cylinder. I will make it 20 mm tall and use vase mode to print the bottom and only one thin wall at the surface. Okay, export the G-code. Open our browser and enter the IP address of the wireless hub. There are only 3 items in the navigation menu. The home is this page, which shows the current job, status, and the live stream of your webcam. The print queue is now empty, and the file manager is also empty. Let's upload the file we need to print, wait a few seconds, and we can then add this file to the queue. Enter 3 as the quantity and 29 as the release temperature, and click Send to Queue. But since we have only one job, it has already been sent to the printer as the current print job, so we can't see it in the queue anymore. Let it heat up to the printing temperature, and it will start printing. Now, it's going to wait for the release temperature. It's showing resetting in the browser, and it won't do anything until the bed temperature drops below 29. Okay, it starts to release the part. The PLA cylinder will gently be pushed away. And now, the status has changed to heating and the quantity 1 out of 3 is now completed. It is going to repeat this 2 more times to finish the job. Now, the status becomes idle as there's no other print job in the queue. Next, I will try to print the same cylinder with PETG. For some reason, the skirt is staying on the bed, but maybe I can set the distance between it and the model to be closer so they will be pushed away together. Finally, 3 of them were printed successfully without problems. However, when I tried to print the same model with ABS, I ran into some issues. The print is sticking well to the bed, but when it's trying to release, the print head just damages the body. I could say it's because the wall is too thin or the bottom sticks too well. So I reprinted the cylinder, but this time I used a 20% infill instead of a hollow body. Okay, now the print head is trying to release the model, it's sticking too well and the stepper motor keeps skipping. As you can see, the temperature dropped to 29 degrees after 40 minutes, but it still can't be released. I would say this flash forged ABS filament sticks too well. This may be a good thing for normal use, but it does not work well with this print surface for auto part release. I have to flex the spring steel sheet manually, and some plastic remains on the surface. Okay, besides using some cylinders to test this kit, I would like to print some of the real models I would normally print. Let's try this crate. I will slice one with a mesh bottom and one with a solid bottom. Upload both files to the wireless hub, add the mesh bottom one to the queue, and just print one copy and use the default 29-degree release temperature. Add another solid bottom with the same settings, and finally, add another mesh bottom with 2 copies. Let's go to the queue. We can arrange the order by dragging the file or deleting it, but we can't change the quantity or release temperature. Okay, the first job is already starting. According to our queue, we will print 1 mesh bottom, 1 solid bottom, and 2 mesh bottoms. After almost 18 hours, we have 4 pretty nice crates. Generally, printing both thin models and printing multiple models at a time is not recommended, but I will try both at the same time and see if the system can handle extreme situations. According to the instructions, the top left corner should not be used as it may affect the print head when releasing the parts. I will move the objects to the right side of the bed, upload the file, and print 4 sets of these. For some reason, the third batch can't be released completely, and it triggered the Prusa Z height calibration as the sensor can't probe the bed, and it is just stuck in this endless Z calibration loop. However, the rest of the prints look okay. After using this kit for a week, I would like to share the pros and cons as well as some suggestions for 3DQ, starting with the pros. As the main purpose of this kit is to do continuous printing, stability is very important. There were no major issues during my entire week of testing it. The software is quite stable, and most test prints are considered successful, except for the one I intentionally made more challenging and the ABS filament that stuck too well. The installation is straightforward, and the instructions menu is well written. With a few simple adjustments to your printer settings and slicer profile, you are ready to go. It also supports almost any USB webcam. I tried all the other webcams I have. All three can be recognized by the wireless hub, although the live stream script has some glitches, and I will talk more about this later. Now for the cons. The print surface may not stick as well as a Build Tech type sticker sheet or a textured PEI print surface. It is similar to a smooth PEI surface, and it may not stick perfectly with all materials. For me, I ended up with some materials that didn't stick well and some that stuck too well. I will further discuss this in the suggestions section. The time required for the bed to cool down from the printing temperature to the release temperature can generally take 20 to 40 minutes, depending on the temperature of the heated bed, releasing temperature, and your room temperature. These are going to affect the time between each print. Of course, you can save some time by printing at a lower bed temperature like 60 or 65 and a higher release temperature, and for some parts I printed with Creality white PLA, they can be released easily at 35 or even 40 degrees. This can cut the waiting time to 15 minutes between each print. So, if you are printing something really simple that just takes 20 minutes to print, it may not be the best idea to use this kit to print one at a time. However, if your print requires a few hours or longer, a 20 to 40 minute wait between each print may not be that big of a deal. Besides that, I would also like to give some suggestions for the manufacturer to consider. For the hardware, add an on-off switch to the box or use a longer cable with an on and off switch. The vapor print surface sticks on the existing PEI spring steel sheet, and with a slider under the heated bed, this is going to add quite a lot of weight to the y-axis, especially when it moves up. It's going uphill as the base is now tilted. Generally, we want the print bed of a Cartesian printer to be as lightweight as possible, as it swings the bed back and forth. 3DQ could consider making a one-piece, thinner, lighter steel sheet with a thin print surface pre-applied on it without using the stock spring steel PEI sheet. A longer steel sheet can also work as a slider, and this can reduce the total weight of the y-axis. For software, I would suggest that 3DQ allow users to change the release temperature and the number of copies for the current job, as well as the jobs in the queue. The webcam live stream stability also needs to be improved. It freezes randomly, but refreshing the page manually does bring it back to normal. I brought this up to 3DQ, and they said they will release an update to address this issue really soon. I would also like to see 3DQ provide a list of approved filament with brands that they tested to work well with this print surface, including detailed parameters like printing temperature, bed temperature, and release temperature. They could also include the types of filament that didn't work well, so we can avoid using them with the Quinly system. In conclusion, this system adds an automation process to your 3D printer by adding G-code between each print that waits for the bed to cool down and moves the print head to knock off the print. It also allows you to manage your print jobs over the network. Some people may ask why you would need this kit when you can add G-code manually to knock off the printed parts and loop the printing G-code to make the printer print continuously. I would say if you are a handy DIY maker who has the skills and has no problem editing all your G-code files with a text editor, then yes, you could do something very similar with no cost. You may also get a Raspberry Pi and install Octoprint with the Continuous Print Queue plugin, which could also do the same thing for a lower cost. However, if you are doing 3D printing production as a business, you don't have the skill or time, or don't want to hire a dedicated person to take care of all of this, you may need a complete package that includes software, hardware, and the parts you need to modify the printer, as well as being provided with technical support when you need it. If all this sounds good to you, the Quinly automation system is something you may want to consider. Besides the Prusa MK3S series, 3DQ also has kits available for other printers, like the Ender 3, which come at a more affordable price. I put a link to their website down below. That's it for this video. If you liked this video, please hit the like and subscribe button. My brother and I make a new video every weekend, so check out my channel on Mondays and you'll see something new. See you next week.